Good evening, everyone. Today we are going to see about Routh-Hurwitz criterion. So it is an analytical procedure for determining the stability analysis. So in control system theory, the Routh-Hurwitz stability criterion is a mathematical test that is necessary and sufficient condition for the stability of linear time invariant dynamical system or control system. So in Routh-Hurwitz criterion, so the number of roots of characteristic equation with positive real parts is equal to number of changes of signs of the coefficient in the first column of array. So what is stability is, so in control theory, especially a stability theory, establish when a system is stable. The number of stability criteria are common as well as it can be taken analysis using the characteristics equation. So this Routh stability criterion, which is used to analyze the stable system, mostly gain of the system. So in case of controlled variable frequency drives, this can be used to study the effect of variation of parameters on any stability driving system. So once we are going for this condition, first we want to know the stability. So the stability necessary components we are going to analyze in the problem is first column. So the first column array must be in positive. If this condition is not met in the system, is taken as unstable condition. So case 1, if there is no sign change in the first column of Routh array, then all the roots are lie in the left half of S plane. If there is any sign change in the first column, then the system is unstable. A number of roots on the right half of the S plane. So in case 2, we are going to determine the auxiliary parameter A of S. So differentiate the auxiliary polynomial with respect to S to get the DAS divided by DS. The rows of zeros is replaced with coefficient of DAS divided by DS. So we are going to continue this construction of array in the usual manner, and the array is represented as follows with respect to the sign changes. So here we are having the condition. If there is no sign change in the first column, the Routh array, then all the zeros indicate the existence of purely imaginary roots of the system or marginally stable. So roots of auxiliary equation. So if it is in positive condition, it is stable condition. If it is not positive, we are going for unstable system. So first element, so if you found any zero value, that can be replaced in sigma. So the sigma is value that can be determined into a zero value. So the determination elements of the array, the resultant array will be as follows. If there is, as usual, the same, no sign change in the first column Routh array. If there is no row with all zeros, then the roots are lying on left half of S plane, the system is stable. So likewise, we are having two more conditions with respect to the sign changes. First column, again with first column, and if you have no rows with all zeros, the roots are lying in the right half of S plane. If there is all zeros after letting sigma is equal to 0, then there is a possibility of roots of imaginary axis. So let us go for the problem. See, the problem is using Routh criterion, determine the stability of system represents by the characteristic equation. So given value is S power 4 plus 8S cube plus 8S square plus 16S plus 5 equal to 0. So what we are going to do is, the solution of the system is, we are going for method of forming an array. So that is with respect to S power n. So we can start whatever the equation is given, you have to start from S power n, then S power n minus 1. So likewise, we can take all the parameters. So how we can write this? So we can see here, we are having here S power 4. So the representation, if the problem is given for S power 5, so here we can take it as S power n. So it is S power n. So next we can take it as S of n minus 1. So S of n minus 1 is also be taken. So these are the systems. First we want to write it is. So first one is see S power 4. S power 4 that is taken from the equation, and write the parameters for S power 4, then S square, then we are having S. Okay, so that is we are going to have the parameters for odd values as well as even values. So if it is S power 4, we have to take the value for S square, and we have to take the value for single value, that is without S. Then S power 3, we can take the the odd and even values. For first it is S4 8, S4 3 is taken as 8, then here the coefficient is 6. So this is taken as row number 1 and row number 2. So next we are going to do, so what we are going to do is, next step we have taken the elements of S3 row can be divided by A to simplify the computation. So already we have written this S power 4 and S power 3. So how we can calculate the system is, we have to take the system, that is we have to cross multiply it. So how we can cross multiply it? So you can see here. So here the values we are having is 8 into 18 minus 8 into 18 minus 2 into 1 divided by 1. So divided by 1 is this value. So we have to start at as 1 into, we have to take it as 1 into 18, 1 into 18, 1 into 18 minus 2, minus 2 into 1, minus 2 into 1 divided by 1. So this is taken as first value. So this is a step. So 1 into 18 minus 2 into 1 divided by 1. So for next value, what we have to do is, so we can see here, again we have to take it the value of 1 into 5. So here 1 into 5. So 1 into 5 minus, here we don't have any value. So 0 into 1 divided by 1. So we'll get this answer as 16. So while we are multiplying it and minus it, we'll get this 16. And here we can find we are having the 5 value. So while we are multiplying the next column, what we have to do is 16 into 2 minus 5 into 1. So you will get this value divided by 16. Okay. So we have to take the first column value. So that is divided by 16. So what we will get is, we will get 1.7. And for the next, what we have to do is 1.7 into 5 minus, so here we don't have any value, so that is taken as 0. So 0 into 16 divided by 1.7. So S0 value we can see here, it will be 5. So this is a procedure we have to follow to identify the coefficients value. So see the first column, there is no sign change. So the system is can be observed as stable system. So we can take this as a stable system. Okay. So see here, whatever the parameters we have taken, and the system is taken as the stable system. So likewise, we can try it for the next problem also.